Thank you, Jeremy. Welcome, everyone. It's a great honour to be invited here to speak to such a big audience. And thanks to the American Farrier Journal and the Hoof-Care Summit for inviting me along. And yeah, thanks for being here. As Jeremy said, my lecture is P3 angle and its relationship to hoof wall angle. And my chosen interest for this study, for my fellowship study, is from my own farrier experiences. So just about me and my journey. I've been a farrier for 32 years, served my apprenticeship local to where I live. And the first 10 years of my career, I was shoeing, I was head down, just shoeing away. 2008, I met my good friend Grant Moon, and I started to take an interest in forging skills and decided to use the new skills that I'd learned. I'd built shoes, I was shoemaking through my career, but my competition interest really raised my awareness of where I could go with my career. So I decided to use the new skills to pursue my associate, which I took in 2010. I became a judge and examiner for the Worshipful Company of Farriers. Competed at Calgary Stampede 2010, rookie 2010, and top 5 2013, which was a great moment. And we won the 4-man draft team Mustad. And that's when then my fellowship project began, 2013. Took my practical in 2015 and passed the fellowship exam in 2017. So that's just about me and my journey, but I've got a general farrier practice in the Midlands. I live in Middle England, and we shoe all kinds, jumpers, heavy horses, race horses. So I've got a mixed farrier practice. There's 5 of us that work in practice together. Some of you might know me for my tool making. Yeah, I make tools. It's another interest. When I get bored of building shoes, I like to challenge myself to make new tools. Me and my son Josh, we have an active interest in tool making. Education of farriers at Central Forge. I run clinics, educational events. And I do some tool development with Jim Blurton Tools, and currently a clinician for Workman as well. We founded a charity, much like your Injured Farriers Funds that you've mentioned here. I'm the chairman and founder of the Farriers Foundation, which is a charity that we run back home for farriers. So that's a bit about me. The Worshipful Company of Farriers, I'll just give you a rundown, an overview of the Worshipful Company of Farriers, established by the Mayor of London in 1356 to regulate and control quality of horseshoeing. So even back then, in the Borough of London, there was a realisation that horseshoeing skills had to be regulated for welfare, for the benefit of welfare. This act was chartered by King Charles in 1674 for the better shoeing and care of horses. In 1889, started the Register of Qualified Farriers, and in 1975, we had the UK Farriers Registration Act, which is a lawful requirement that we should all carry a minimum of the diploma. So my fellowship research project began with an interest in remedial work, which my job had taken me more into specialising in remedial foot care. I work at Pool House Equine Clinic, which is a local veterinary clinic near to where I live. I do 2 days a week there now. So this collaborative study started at the Royal Veterinary College. Jointly with Grant Moon, we did a research project at the Royal Vet College, and I have a great deal of gratitude to the Royal Veterinary College and Renata Weller, who you see in this picture, Professor Renata Weller, who's the head of research. And without this link with the RVC, it would have been very, very difficult for me to pursue this financially and and in terms of educational knowledge. The RVC have been founded in 1791, so it's been at the forefront of equine research and veterinary research. So in this fellowship project and in this presentation, I'm going to discuss the apical angle of distal phalanx, and this is the terminology that I'll be using, and I'll explain as we go through the lecture. I'm going to talk about how the study was performed and discuss the trimming protocols that we used in this research project. Computed tomography, CT scans, that's the analysis that we used was all off of CT. Statistical analysis, I'm going to talk about our statistical results and the practical uses of measured apical angles, followed by conclusion. So we start off with the term apical angle, often used in medical terminology to describe an apex or an angle of a pyramidal shape. The word's derived from New Latin, apicalis. From my interest in, obviously, with my work, I use a lot of radiographs. I'd say perhaps 10 or 15 horses a week I'm evaluating from radiographs before and after shoeing. So this was my initial interest, was how much does this angle vary, and what is the relationship to the dorsal wall and the weight-bearing surface. So the apical angle refers to the basal angle, the apex angle. And it was my belief, it was my thought that this, there's obviously some resemblance to the apex angle to the dorsal wall to weight-bearing surface. So the aims of this study, using CT imagery to collect angular measurements of the apical angle and test the data to the relevance of variations of the angles relating to P3. We'll measure the positional angles of the distal phalanx in the group data set, Palmer and Planter. And we'll compare the measured angles of P3 before and after trimming using an applied hoof mapping technique. I'll explain more as we go through. So to determine foot conformation parameters in the front and hind feet, both before and after trimming, it was hypothesized that there would be a positive correlation between the apical angle of the distal phalanx and the angle of the hoof wall to weight-bearing surface. Also, this correlation will be stronger in the trimmed feet compared with the untrimmed feet. And also, the positional angle of P3 palmar angle can be altered by foot trimming using visual reference points on the hoof from an applied foot mapping technique in front and hind feet. So this study was performed on cadaver limbs. The limbs were 100 fronts and hinds, 50 fronts, 50 hinds. The animals have been euthanized for unrelated reasons, approved by the Ethics and Welfare Committee of the Royal Veterinary College. So none of the horses, we didn't know the history of the horses, but most of them had been euthanized for various reasons, so there wasn't one particular reason. They were all transected carpus, tarsus, various breeds of horses and ponies. The aim was for 50 fronts and 50 hinds. This was a collaborative study, so marking out and mapping, photographic records, weighing and measuring, and the benefits of this study being carried out at Royal Vet College meant that we could use some of the vet students as well to help us with the weighing and measuring and cleaning. So to start off with, 100 limbs were brought out from freezer storage at RVC, cleaned, weighed, measured and photographed. So we had a clear and concise plan at the beginning of how we were going to conduct this study. So there's as many as 8 people at one point working on this study, helping us weigh and measure. As you see Grant Moon in the picture there, we managed to find some overalls to fit him. just about. I think he tore those ones when he was taking them off. So we had to keep finding new overalls for Grant. You know, we squeezed him in. But that was in the lab, foot trimming and cleaning and hoof mapping. Planning and logistics. I'll talk more about this as we go through, but for anyone embarking on any research project, you'll know how important it is to pre-plan and have a clear plan. I actually started a couple of other research projects before I got involved in this study at RVC, and due to poor planning, things went wrong partway through, and I abandoned a couple of studies. So I started to begin to realise the importance of a clear plan and knowing exactly where we were heading. Grant, of course, is a great logistical planner, and you see him there with Renata Weller in discussion in his new set of overalls. And also, we discovered that vets like donuts nearly as much as Grant. So every visit to RVC, we took a pack of donuts, and it all helps. It helps with the team spirit. So we managed to polish off a good few donuts during this study. But throughout that, management discussions, a lab book, it was really important to have that set down so we all clearly understood, because it was a big team. And although myself and Grant were heading the team alongside being guided by Renata, we had to discuss with the vet students how we wanted things to be done, because there's no good going back over the data and finding that we'd missed things out. So planning and logistics were an important part. So for the purpose of the study, we had to apply a trim protocol for consistency. So loose and exfoliating sole was removed from the cadaver limbs, and the heels were trimmed to the highest and widest point of the frog. And I'd like to emphasise the highest and the widest point of the frog, as that was one of the criteria we set down. We agreed the foot map that we were going to use, and not the widest point of the frog, which some people use as a trim protocol. We used the highest and widest point of the frog, and I'll talk about that because that's an important part of our data in the results. But basically, balance and symmetry was the aim. So, as a farrier, even on a cadaver limb that's not necessarily no longer connected to a horse, we can still have a good idea of balance and symmetry, and that was the aim. And that was where I came into the foot trimming part of this as the experienced foot trimmer. I'm not saying that Grant isn't, but we decided that one of us had to trim all the feet for consistency, so that was my job, unfortunately. As there was 100 feet, it was quite a big job. So the applied foot mapping technique, some of the pin markers on this diagram were relative to Grant's study as well, because he further to my study, his current study is foot mapping techniques. But I did find that the foot map, the grid, helped me get a good idea of balance and symmetry. So as you can see here, this was an important reference point for us. The red line, as you can see on the diagram, center of rotation of the DIP joint, and I'd say that was for my part of the study, that was quite a valuable reference point. And we used the widest point of the white line on the cadaver study, not the widest point of the wall, which if you've got a distortion in the wall, obviously the white line is a more reliable place. Highest and widest point of the frog. So these pins related, the external pins related to what the internal reference points were. But we had to have this technique applied, because it would have been no good just saying, oh yeah, John Nunn trimmed the feet and he knows how to trim feet. So we applied a foot mapping technique. We're not necessarily saying this is the correct way of trimming feet to this map, but for the purpose of this study, we could guarantee consistency. So that's how most of the foot trimming was applied. I didn't use a jig, didn't use a vise. I just sat down on a stool and trimmed between my knees. I tried to replicate how I would trim a normal foot. And there was piles of bodies around, you know. I'd never seen so many dead feet, dead legs. And we worked into the night because these feet had been frozen, so we wanted to try and not have to keep refreezing them to then possibly affect our findings. So yeah, we worked long and hard. I think that was like 12 o'clock at night. That was 12 o'clock at night, that one. We were finishing off the first day after mapping and CT scans. Because after the initial map, then the feet had to go into the CT scanner. So this just gives you an idea of one of the feet, foot number 11. And we've got a massive inventory now of trim feet with CT scans. And the CT imagery, it's very accurate. The reason that we use CT, it's more accurate than a radiograph. So we could take measurements from CT, and they're actually real-time measurements. So CT imagery is a lot more accurate for us for this study. So this is 3D rendering. So the CT imagery is done in slices, and it's a very powerful radiographic image. Then we can build it back up into a 3D image, and as you can see, the video on the right is what the rendered image can look like. So I don't think there is an amount of feet that have been studied under CT imagery, and 3 or 4 people have taken data from this same study. So we've got a great pool of images at RVC, you know, a great library of CT images. But the interesting thing for me, I spend hours going through these CT images, and one of the interesting things from this foot number 11 is how the small notches in P3 reflect in the hoof wall, the untrimmed hoof wall. Interestingly, I suppose it makes sense that the hoof wall is going to reflect what is within, and if there's small notches in the pedal bone, but it was great. It was great to have these images and go at our disposal. And that's what the CT images look like. The scanned images. So we used Ella Fitzgerald was our CT technician. Obviously, ourselves we couldn't take the images from CT. It's very difficult to take measurements without being a trained technician. So these slices were built into 3D, and this multiplanar view gave us an accurate mid-sagittal. So again, the benefit of CT is we could find an exact mid-sagittal plane to take the measurements from. So these are the measurements that we were looking at: P3 position, palmar and plantar angle. It was decided after the beginning of this study, where the initial was, I wanted to measure the apical angle of P3. It was decided that we'd got to figure out the palmar angle as well. And the image on the right here is, I think, what most veterinary surgeons apply to farriers in terms of foot balance. We use the dorsal measurement of P3, the measurement of the dorsal wall in comparison to the dorsal hoof wall. And before I started to think about this apical angle, I actually thought that vets used the measurement term, the apical angle. I didn't realise that a lot of the time most vets in the UK don't consider the apex angle of P3. So this is an image. Again, all these the red lines are all the measured images from CT, what we took. So this diagram demonstrates dorsal hoof wall to weight bearing surface was measured and compared to the apical angle of P3. And we also measured the dorsal hoof wall to weight-bearing surface to the dorsal surface of P3 to weight-bearing surface. And we analysed those statistics and formed our results from these measurements, and also considered palmar angle. So we figured out the palmar angle, although we didn't measure the palmar angle for CT, we subtracted the apical angle from the dorsal hoof wall, from the dorsal surface of P3 to weight-bearing surface, and that gave us a palmar angle. This is the boring bit. The statistical analysis. I'm not a mathematician, and statistics scared the living daylights out of me. And previously, until this study, if I saw a page of numbers, I'd have a meltdown. And I started to read about statistics, and then found out that William Seeley Gossett he worked for Guinness, and he invented the student's t-test to measure consistency in the Guinness. So I thought, well, yeah, that's got to be a good thing. We all like a pint of Guinness that's consistently good flavour, and we can thank William Seeley Gossett, but also for the fact that the student's t-test was invented by William. And you begin to realise that everything in our life revolves around a lot of numbers and statistics. So for this study, we used the Kolmogorov-Smirnov test. So that determines if the two data sets differ significantly. So really that's a significance test. The Wilcoxon-signed rank test compared the average of two dependent samples and assessed for significant differences, and the paired t-test and Pearson's correlation coefficient provides a hypothesis test for the difference between the population means. So we used various statistical tests. We didn't just use the t-test. Again, advised by Renata, who's an excellent statistician. Can't even say it. We had to use these tests in our study to help us with the results. So this is some of the numbers, some of the interesting numbers that we found. So dorsal hoof wall to weight-bearing surface. So as you can see on this diagram here, we got dorsal hoof wall to weight-bearing surface, post-trim, pre-trim and post-trim. So 49 to 52 degrees. On the hind, 51 to 55 degrees. So we can ascertain from that the mean average, so averagely across the data set, we altered the angle of dorsal wall to weight-bearing surface 3 to 4 degrees, which in my mind, it figures. Most of my trimming that I'd carry out on a normal foot, I'd think I was adjusting to a positive plane by 3 to 4 degrees. So that supported things that I already knew as a farrier. The apical angle of P3, so the mean apical angle in the front was 47.32 degrees compared to the hind, 49.68. And the minimum to maximum apical angle of P3 was 41 degrees to 55 degrees. So then we began to realise there's a significant difference in the front feet, in the angular measurement of the apical angle. In the hind feet, 45 to 58 degrees. So again, there's quite a significant difference in the apex angle of P3. This was a radiographic view, so I wanted to try and use something as farriers that we recognise. So we used the radiographic view and measured the apical angle. So 13 to 14 degrees, maximum to minimum. So the angle of P3 mid-sagittal. So this was diagram 2. You can see angle of P3 mid-sagittal solar margin. This was 27 degrees in the front, minimum, maximum to 42 degrees. So this was in the group data set of 50 feet. It varied from 27 degrees was the lowest angle to 42 degrees, which is the highest angle. So that was quite a variance of degrees of angle, 15 degrees maximum to minimum. In the hinds, 25 degrees to 45 degrees. So 20 degree difference in the hinds, minimum to maximum. And again, I would expect in the hind feet the P3 mid-sagittal to be a steeper angle, to be a less steep angle, sorry. As we believe the hind feet is more deeply vaulted, so that would make sense. The solar angle is deeper in the hind feet. But it's interesting, the angle of variance, and we discussed this quite a lot during the analysis of the results, and how much we think this is going to affect the angle of insertion of the deep digital flexor tendon. You know, the variance of angle 20 degrees. You know, to me that's quite a significant amount of variance of angle. So solar angle on this diagram, we've got solar angle, but this means palmar angle. So palmar angle in the front feet, 3.12 degrees. In the hind feet, 3.86 degrees. So again, that falls into the norm as we understand it, 3 to 5 degrees positive palmar angle. So we could support some things with this evidence. We could support the fact that, you know, in literature reviews, we believe it's published norm. The published norm is 3 to 5 degrees positive. The thing that we had trouble figuring out really was before trimming, we had six of the front feet had a negative palmar angle, and this increased to 10 post-trim. So this is one of the questions that really remained unanswered. And in the hind feet, we had 7 feet that had a negative palmar angle, and that increased to 15. So in our discussions afterwards, we discussed the foot map, whether the foot map was actually effective. And I felt as a foot trimmer, even though we were trimming to the highest and widest point of the frog, I felt the foot map was encouraging me to lower the heels, probably more than as a farrier that I would do practically. So, and we used the highest and the widest point of the frog for our foot mapping technique, not the widest point of the frog. So is my belief personally, if we'd have used the widest point of the frog as our trim map protocol, yeah, we would have had a larger number that would have gone negative. But also, we didn't know how many of these horses were lame beforehand, so it could have been they'd had the whole life like that. You know, out of the group data set to get 7 feet out of 50 that have a negative plantar angle, because this was a hind foot, it probably wouldn't be unusual in a normal group of horses. So, results and statistics, we did find the distribution was normality tested using Wilcoxon's. The most significant results of tested parameters showed a highly significant, strong correlation to the dorsal hoof wall to weight-bearing surface compared to the dorsal surface of P3. So we knew that we achieved better alignment after trimming with this measurement. A strong, significant positive correlation post, especially in this result. So, kind of from this, using the apical angle, I formulated my own extra test, which you might read in the appendices, which I recommended for further study, which I'm going to discuss now. So I figured that the apical angle of P3, radiographic view as you see on this diagram, plus 4 degrees, which was the mean Palmer angle, should give us the dorsal wall to weight bearing surface measurement. Seeing as we'd had a correlation of these two statistics, so we ran the statistics again with this measurement. So we added 4 degrees onto the apical angle of P3, and we had a significant positive correlation in this statistical test. So from that, we can assume, we can calculate that a measured angle of dorsal hoof wall to weight bearing surface could be ascertained. But again, this requires further study, and that's something that my studies at Poolhouse Vets, I'm continuing with that. I like to give credit to some of the horses that I shoe, and Finley has been one horse that I've learnt a lot from. Certainly with my study, it's very important to look at Finley's radiographs, and this is something that I'm going to talk about in my breakout lecture tomorrow. Is the angle of P3 and how we can affect the angle of P3 as farriers with remedial shoeing. So this is Finley was a horse that came into the vet clinic, and he got, as you can see, the pictures are the right and left front feet before and after shoeing. He got a reverse rotation of P3. So these pictures on the left, as you can see, that was before shoeing, and the pictures on the right are 15 minutes after. And really not a great deal of dorsal wall rasping, not a great deal of dorsal wall removed. But again, Finley's one of the horses that I've been studying the apical angle of his pedal bone and how it relates to the dorsal wall. So the technique I used for shoeing Finley was a heart bar with a leather pad. But I think you can see a significant difference in the positional angle, certainly. And as farriers, it's really important to be able to evaluate this. So the radiographs of Finley before and after were quite interesting, and not many of us have the opportunities of seeing X-rays before and after shoeing. Many of us are presented with X-rays before shoeing and never see a post X-ray. So this was my shoeing technique that I used on Finley. Again, I'm going to discuss this in more detail tomorrow in the breakout lecture. But frog support was really important in Finley's recovery. You know, a shared load and helping the position of P3 into a positive angle. I tend to use a heart bar with a leather pad, so that's my preferred method. I've found I do use different hoof gauges. I don't, as a rule, as a farrier, I don't apply angular measurements. But for the purpose of my study, I felt that it was important to try and support my theories. No. So before there was an open heel shoe on there before, yeah. But Finley's heels were really low, as you can see from the picture here. They were really low, and I loaded that frog, you know. And I'm not afraid to load a frog when needs be. But the leather pad kind of helps soften the pressure. So I tend not to get so much frog atrophy when I load the frog with a leather pad as well. So it's a technique that I use a lot at the vets, and to restore the angle of P3, and I think provide some comfort for a lame horse. I find it a very effective method. But just for the purpose of this study, I used Finley's feet as an example of before and after, and I measured the angle of the dorsal wall to weight bearing surface. I found the Dolmer hoof gauge and reading reviews on different hoof gauges, many of us traditionally use hoof gauges that are non-weight bearing. So I wanted to use a weight bearing hoof gauge, and the Dolma hoof gauge is one of the only ones that I know of that measures the angle of a weight bearing hoof. And it's simple to use, it's quick, it's not fancy, the horses don't get upset by it, so you can measure an angle very quickly. So I found it's a useful tool in my box, and it's fairly simple and cheap to buy. So I proposed like measuring the angle of P3 to calculate hoof wall angle. So the apex angle, as you can see on the picture on the left, we've got 44 degrees apical angle. And the hoof wall angle, this is Finley's feet before and after shoeing. So December 2015 was when I first saw Finley, and the previous X-ray slides what you saw. So you can see from the radiograph and the lines that I've drawn on the radiograph, the apical angle is 44 degrees. So add 44 degrees to the 44, it gives you 48 degrees. So I kind of had 48 degrees in my mind as that was where we needed to be, somewhere near 48 degrees. But actually the dorsal hoof wall to weight bearing surface was 42 degrees prior to shoeing. So by May 2017, I've got quite a good collection of Finley's radiographs before and after shoeing, and it improved the dorsal wall to weight bearing surface, we'd improved the palmar angle, and we've actually got a 51 degree on the radiograph on a measured angle. And again, I'm going to talk about this more tomorrow. The heel bulb shape, what's significant pre and post shoeing with frog load, and we've engaged the digital cushion, and I think that's a really important part of this, you know, and what we see an improvement of palmar angle is frog load and the digital cushion starting to engage some weight and share the load. And again, I use the word shared load because I think a lot of these horses' feet, when they get tired and they've prolapsed frogs, you know, the frog's crying out for support. So it's a really important part of my restorative approach to these feet. So again, heart bar and for support with frog pads. Centre of rotation. I'm not one for drawing lines on all the horses I shoe, I don't do this, but for demonstration purposes, I think this is what we see. This is what we look at as farriers. This is when we look at a radiograph. But all too often, we're still shooting from the hip. Even with radiographs, we're still not applying a measured technique. So, in my mind, this was an approach to where we could use a measured technique, which would be helpful to us in farriery. And it's a guideline, not a rule. And I'd say, certainly for me, again, a comparison of Finley's feet from December 2015 to May 2017. Centre of rotation is actually in a different position. So do we believe that centre rotation is a movable? I think it is. I think when you engage the frog and support the frog, P2 certainly, if it's subluxated, you can do a lot to restore the position of P2. And I think without that, these sort of feet are going to be hopelessly reverse angles. So frog support, frog load is really essential to me. So these are a few hoof wall measuring devices that I use. This one I just bought. I bought a digital angular measurement device, and I made a metal object to fit it to. It's got magnets on it. So in case we've got any deviation in the hoof wall, I just had 2 flat spots, top and bottom. So I use that for measuring feet and the Dolma hoof gauge. And I find that I find that quite an effective way of measuring. So now there's a lot of these kind of digital angular measurement devices on the market, and make it quite easy to measure the angle of the hoof on the ground. These ones, these hoof wall gauges tend to be non-weight bearing gauges. So for me, it's important, I think, if we're judging angular measurements from a radiograph is weight bearing. So does it make sense to apply an angle to that hoof when it's non-weight bearing? To me, any angles that I apply from a radiograph has to be a weight bearing angle. So in conclusion, these results strongly suggest that the distal phalanx alignment can be improved with a trimming and hoof mapping technique. And also that there's a large range of angles of variance within the hoof, and this was apparent from this study, the variance of angles. So applying a fixed angle, a fixed ideal angle, I think it needs to be more individual. So from my perspective as a farrier, I think measured angles from within the hoof are really important for us going forward as farriers to apply effective techniques to these feet that have gone wrong. And this was just some other ideas that I was having with a low apical angle. You know, could we then figure out how much angle of graduation we need? I think we could. So a measured angle of the apex, maybe we can figure out an exact graduation and how much graduation we need to apply to some of these feet to correct them. And I think greater accuracy in treatment originates from within. And so for me, as a remedial farrier going forward, I feel that I need to have more accuracy in my farrier techniques. And yeah, I mean, I shoot from the hip. I shoot what I see in front of me, and it usually works. But in summary, I've discussed the apical angle of the distal phalanx, and I hope that's clearly understood and you know what the apical angle is. How this study was performed, applied trimming protocols, the statistical analysis, and the practical uses of measured apical angles as a farrier. And this is at early stages of a study. It's still an ongoing study. I'd like to do more with the apical angle and how it relates to the dorsal hoof wall. I'd like to acknowledge Professor Renata Weller and Ella Fitzgerald, the Royal Veterinary College, Paul House-Equine, Grant Moon, and Sean Millard, who was a joint veterinary researcher on this project, Tom Underhill, Mark Trussell, and Simon Moore, and a great deal of other people who helped with this collaborative study. So I've spoken to some of you the last few days who were thinking about going on to do your fellowship dissertations, taking your fellowship exam. And if there's any advice I could give you is ask a clear and simple question, because my study started on my interest in one angle, in the apical angle of P3, and we've got a massive data set. We've got a huge amount of information from this study. So don't try and overcomplicate it. You know, if you're thinking of doing your fellowship, sometimes the simplest questions can be very complex. Have a very clear plan at the beginning. Create a lab book, a notebook, and write down the questions that you want to answer. And it's the same with any research project. So many of us begin a research without a clear plan and a clear question of what our objectives should be. I would recommend that you affiliate your study with an educational establishment. I was very lucky that RVC allowed me to become a part of this research project. The funding from this was through the RVC. So the fact that veterinary students were funded, but these CT images would have cost in excess of £10,000 if we'd have had to pay for all of that. So there's great benefits of affiliating your study with the university. Funding and education, I'd say, are two really good reasons, because I just wouldn't have got where I've got if I hadn't have had some assistance with funding. Before you start, learn how to set out a scientific paper. Again, it took me probably 3 years from the beginning of my decision to take my fellowship. It's been kind of a 3-year project. But if you learn how to set out your paper from the beginning, then like I rewrote probably 20 times my paper. And if anyone wants a copy, and come and see me at the Jim Blurton booth or the Workman booth, and I'll make sure you get a copy. And I think you've got something in the presenter notes of my dissertation. But that's really important. Like writing a scientific paper, it's complex, and you need to know how to set it out to make it understandable and readable. And you can waste a lot of time, like I did. Joint research projects can have a lot of benefits. We shared a lot of thoughts and ideas with Grant. I shared a lot of donuts, although he had most of them. So joint research projects, I'd recommend, if you can, become part of a joint project. You don't necessarily have to have the same data that you draw from it, but certainly with the CT imagery, from my part of it, there's 4 or 5 people already now still using the imagery that was provided at RVC by our research project. Take lots of photographs. Carefully record your measurements, and because you don't want to keep going back over it. You can't. Sometimes if you do a live horse study, those measurements are gone. You can't go back over it. So make sure you take a lot of information and photographs and measurements. Thanks for listening. I'll be happy to answer any questions. And
did you find the difference? What was the difference between measuring foot angles, weight bearing versus
that's probably a study in itself, and it has been done by Micah Van Heel and Molman. There's a study that goes into that, and from the results of that paper, again, I used that paper as a reference in my dissertation, and the Dolmer hoof gauge was found to be the most accurate of the hoof gauges that they used in the Molman study. So again, that's an interesting read. It's a short paper, but they compared non-weight bearing hoof gauges to weight bearing hoof gauges. So that's kind of where I came from with why I used the Dolmer hoof gauge, because it was from Micah's study. They found it to be most accurate. Yeah.
Jonathan?
Thanks for listening. And
hold on, we have one question right here.
Oh yeah, Adam. Yeah.
I know this is a bit outside the scope of your study, but with such a large variation in the apical angle of the coffin bone, did you happen to either notice, or would you be able to return to the data of your CT images to see what the relationship of the length of the pastern was in relationship to the, did you?
I didn't. Yeah, this was a huge study in itself. So again, the opportunities for people to use that CT imagery is still there. So I mean, I'm sure Renata Weller would allow access to that information, and they're running courses at RVC. I think they've just started a course in the US now as well, for for people wanting to take their fellowship. But the CT imagery could, it can be reused, and you could easily measure the pastern length, did you say, compared to the...
just to see if there was any sort of correlation between the longer pasterns and the lower apical angles of the coffin bones.
Yeah, that'd be really interesting. And I know that Renata's interested, and she's written a paper on the solar angle, so a mid-sagittal solar angle, and how it relates to the angle of insertion of the digital flexor tendon. So I think from the results of their study and other studies similar, it's been proven that horses with a lower angle of P3 have a more higher incidence of injury or a predisposition to injury of deep flexor or deep distal impar ligament. Mm-hmm. So yeah, I guess the apical angle will come into this as well, and it's been it hasn't been used as a reference. So the apical angle, horses with a low apical angle, I'm guessing would have a stronger predisposition towards injury. Yeah.
Okay. Good work.
Could be your next one.
I don't know.